All right, we're still graphing using transformations, but now we're going to step it up a notch and we're going to be bringing in some stretching and compressing. Not only do we have numbers being added or subtracted to our parent functions, but we also have numbers being multiplied as well. So let's just go ahead and work through the example. Let's start with example 4a. And I see that I have a plus 4 on the outside of my function, which means you're going to move it up 4. And I see that I have a plus 3 on the inside of the function, which is a left-right shift. And it's going to be opposite of what you think. So that's actually to the left 3. So numbers on the outside, up, down. Numbers on the inside, left, right, and opposite of what you see. And then I also have a number on the outside being multiplied by my function, and when it's on the outside, that is going to be a vertical stretch or compress, and this is actually going to be a vertical stretch, and it's going to increase my y values. It's going to double my y values. And then I also have that reflection right there, which is over the x-axis. So you're going to reflect x. I usually just write flip, but I'll write it properly this time. You're going to reflect over the x-axis. That's too much writing for me, but there it is. Okay, so let's go ahead and figure out where our new origin is first of all. Our new origin is going to be left 3 and up 4. 1, 2, 3, 1, 2, 3, 4. That's where our graph is going to move. You are going to ignore all the numbers on the original XY axis, and you're going to pretend that this is your XY axis. So if you were graphing your parent function the way it normally would be graphed on the real XY axis, we're now going to graph it here. Except this time now we have a vertical stretch of 2 and a reflection over the x-axis. And let's just talk about what our parent function is. I don't think I've done that yet. It is the absolute value of x. So take away the 3, the 4, the negative 2, and there you have it. It's going to be a v. And normally that would be over 1, up 1, over 2, up 2, back 1, up 1, back 2, up 2. That's the regular parent function graphed in your new origin with just the left, right, up, down shifting. Now our graph is going to be reflected over the x-axis. So now our graph, instead of going over 1, up 1, we go over 1, down 1. Instead of going over 2, up 2, it's over 2, down 2. You reflect over the x-axis, which means your y's are in the opposite direction of the normal parent function. Okay, so back 1, down 1, and instead of back 2, up 2, back 2, down 2, and that is the parent function moved left 3, up 4, and flipped upside down, reflecting over the x. We have one more thing that we have to do, and that is a vertical stretch of 2. If the number is being multiplied on the outside of the function, you are going to take that number and you are going to multiply it by the original y values. And so I'm going to be doubling all my y values. So we start at 0, 0. Instead of over 1, down 1, I have to be down twice as far. I have to double that amount of y movement. So I'm going to be over 1 instead of down 1, I'm going to be over 1, down 2. And instead of being over 2, down 2, I have to double that y movement, and I'm going to be over 2, down twice as much, which would be 4. So normally I'm over 2, down 2. I'm now going to be over 2, down 1, 2, 3, 4. And then it's going to be the same thing on the other side. Instead of back 1, down 1, I'm back 1, down twice as much. So that's down 2. Instead of being back 2, down 2, I'm going to be back 2, down 4. I'm down twice as much. and then I can go ahead and draw in my graph. Okay, so that's kind of crazy with all of those different graphs I drew in there. You don't really need them all. But only for the example, I just kind of wanted to take you through the process and give you a nice little concrete thing to look at while I discussed what I was doing. So technically everything that's in blue, gone. So our graph was shifted to the left 3, shifted up 4, reflected and flipped over the x-axis, my pretend x-axis, and then also all the y values were doubled. So instead of going down 1, I went down 2. Instead of going down 2, I went down 4. Instead of going down 3, when I go over 3, down 3, I'd have to go over 3, down 6. All right, let's go ahead and do this one right here. This is, I think, a little bit easier because there's not so many numbers on it and there's no minus sign on the problem. Okay, so we have our parent function is f of x equal to the square root of x. Take away the 2 and the 6 and you have the square root of x. That normal function goes over 1 up, 1 over 2 up, 4. Looks like that. And so let's go ahead and look at all of our transformations. When you have a number that is inside your function being multiplied, being multiplied, you need to make sure that you get that x term to just be plain old x. You need to make sure that you factor out the 2 off of the x that's here. And so we're going to rewrite our function with that 2 factored out. I don't know what I picked. What did I just pick here? So you're going to have 2 times the quantity x plus 3. Now that you have your x term as 1x on the inside here, and you factored out that 2, you now can work through this problem using transformations. If you left that 2 alone, right smack up next to the x, and didn't factor it out, then you would not get the correct graph. Okay, so our shift has now changed. We do not have an outside shift up and down, but we have an inside shift. It is no longer to the left 6, it's now to the left 3. So we're going left 3. And a number being multiplied on the inside of your function is going to be a horizontal stretch or compression, and it's going to be opposite of what you think. When we look at example 4a and we were multiplying by 2, it was actually stretching our y values and doubling them. It is the opposite for when you're on the inside of the function. Multiplying by 2 is going to compress the x values in the function. It's going to compress the x. So outside affects the y, and if I say I'm multiplying by 2, I multiply my y values by 2. If I say I'm having them, then I divide my y values by 2. But if I have a number on the inside, it's not going to do the same. It's going to affect your x movement, and it's going to be the opposite of what you think it should do. So instead of doubling my x movement, it's going to half it. Just like instead of instead of moving to the right 3, when you see plus 3, you go backwards. You do the backwards for the multiplying and dividing. Instead of doubling and stretching my x, it's going to compress it. It takes a little while to get used to. It's a little strange, but you're just going to have to practice it. So let's go ahead and find my shifting. My shift is to the left 3, so I'm going to move over 3. I don't have an up-down shift, so this is going to be my new. XY axis right here. The normal graph, the regular graph of the square root of x starts at 0, 0, goes over 1, up 1, over 1, 2, 3, 4, up 2. A number that's being multiplied inside the function is going to have the opposite effect of what you think it should have. Instead of doubling the x movement, it's going to half it, and it's going to compress it. So I still start at 0, 0. But instead of going over 1, up 1, I go over half as much. I go over a half, then up 1. The y movement doesn't change on my original parent function. It is the x when you're underneath. And then instead of going over 1, 2, 3, 4, up 2, I'm going to go over half as much. I'm going to go over 2, and then still up 2. Y movement the same, x movement is halved. And then I can go ahead and graph that. And you could go further if you wanted to. If I put a 9 in for x in the parent function, I get back a 3. So normally it would be over 9 up 3. But in my compressed function, it's going to be over 1, 2, 3, 4 and a half, and then up the regular 1, 2, 3. Ooh, I did that pretty good. Got pretty close to where it should be. So that is the proper graph, and you can go ahead and erase. Or you could leave it. Just make sure if you're leaving all the extra stuff that you're drawing on here as guides, like all your work that you're using as just a guide, just make sure that your final function is like bolded out, or you color code it, or you draw in with a highlighter. You just make it really stand out.